Algebra 2, we're in lesson 7.2, and we're going to be converting between a radical and an exponent. Look, if you have an exponent that is a fraction, look at this, 1 over n, what you're going to see is that is equivalent to the nth root of a to the first, which is the same thing. A to the first is just an a. What you're seeing is the denominator will tell you what type of a root you really have. So let's do some of these problems together right now. If we take a look at number 1, we've got a 7th root of b to the 5th. The directions say write it as an exponent. Well, the index always is in the denominator. So this is really b to the 5/7. Take a look at letter B. A square root is really a second root. They never write the index in there. You have to be aware of it. So this is going to become x to a power. Remember, the index goes in the denominator. That's x to the 1/2. Here, as we look at a 5th root, the 5th root of z here, this is going to become z to the 1/5. And finally, right here, we've got 14 to the 1 inside. That's a second root. That's 14 to the 1/2. Again, you can see that that index always is showing up in the denominator. Now, we can go in the opposite direction. We can start with an exponent and write it as a radical. Again, what's the common theme? It's this denominator. That denominator will tell you what type of a root. This is a 3rd root. And again, just pay attention to that. That's really going to help you out a ton. So at this point, this becomes 10 to the 1, which of course, that's just 10. So you just write it as the cube root of 10. Likewise, right here, a denominator of 4 tells you that's a 4th root of 5 to the 1. Well, that's just the 4th root of 5. This thing right here, a denominator of a 5, tells you that's a 5th root. The 5th root of 7 to the 3rd. And finally, right here, we have the 3rd root, that's your denominator, of x squared. These problems you can do very quickly. Let's keep going. Let's take a look at number 3. And my goodness, have a calculator out because this problem is most easily done directly. Just go 25, raise that up to the 3/2 power, and we'll get 125, and you are done. That's all you have to do. 16 to the 3/4. Well, here we go. 16, bump it up. Alpha y equals, and we'll go 16 to the 3/4 power, and we'll just get an 8, and we are done. Take a look here. If I had x to the 2/3 times x to the 5/9, you might remember from an earlier chapter, x to the m times x to the n. This is where you add your powers together. So take 2/3 plus 5/9. You can add this by hand, or you can add this via your calculator. If you've struggled with fractions, just use your calculator very quickly to get assistance. So you get 2/3 plus, and over here we'd get 5/9. And very fast you'll get 11/9. X to the 11/9 power, and you are done. For this one right here, we're going to add our powers again. Here's 3/4 plus 1/2. And again, just get some assistance. We'll go alpha y equals, get 3/4. Move this over, say plus a 1/2. Of course, we know 1/2 is really 2/4, don't we? You can even add this very quickly. You should get 5/4, and you do. All right. Well, the quotient rule. If I gave you x to the m divided by x to the n, hopefully you remember what we did there. This is where we subtract m minus n. So this is x to the 3/5 minus 3/4. And plain and simply, that's what you do. You go 3/5, and we'll say minus alpha y equals 3/4. There is an added part of the directions. We should always read the directions. This is x equals negative 3/20. You're answering only with a positive exponent. That's what I'm talking about right here. We need a new property. The property being, which we've seen before, when you have a negative exponent, take your reciprocal, move that term to the denominator, then write it with a positive exponent. Finally, as we come right here, we're going to subtract. We'll have 1/2 minus 2/5. And we can get this going very quickly. We'll bring this up. Here's our 1/2 minus, and we'll get our 2/5. And you'll get 1/10. You don't take a reciprocal here. You leave it as is, because it has a positive power, and you're done.